Hey guys, Mr. Backerberg here. In this video, we're going to look at the inverse sine function. So as we're looking at the graph of a sine function, and as we're specifically thinking about finding an inverse, to graphically check if a function has an inverse, we run the horizontal line test. So if I drew in a horizontal line on my graph, I can see that this line would intersect my graph at more than one place, meaning that right now it doesn't have an inverse. But instead of looking at the entire graph, if we chose to restrict down the portion of the graph that we can see, then we actually can end up with an inverse. And what we're going to do is we're going to restrict down our graph to being between negative pi over 2 and positive pi over 2. So we're going to pretend the stuff on the left doesn't exist, and we're going to pretend the stuff on the right doesn't exist. Then, if I draw in horizontal lines along this middle chunk of my graph, I can see that those horizontal lines are only touching my line at one point, which means that we will have an inverse as long as we're only looking at this small chunk of our graph. So the unique angle y in the interval from negative pi over 2 to positive pi over 2, such that the sine of the angle y is equal to some x value, is the inverse sine, or we also call that the arc sine of x. Now there's two different ways that we could see the inverse sine written. One of them is the sine with a negative 1 power on it of x. That means the inverse sine. Or we can also call it an arc sine. So we could say the arc sine of x. Both of these mean exactly the same thing. These are both an inverse of the sine function. Now as we're talking about the domain of an inverse sine, the domain is the values from negative 1 up to positive 1, and our range will be an angle somewhere between negative pi over 2 and positive pi over 2. Now, as we're thinking about these inverse sines or these arc sines using our unit circle, the angle pi over 2, well, if we're starting at 0, the angle pi over 2 would move us up to this positive y-axis. And if we're thinking about the angle negative pi over 2, well, it's going to be a quarter rotation, but in the negative direction. So that means backwards this pi over 2 distance. So as we're looking for angles using our unit circle, we're going to be focusing on the right-hand side of our unit circle. So we're going to look at doing some examples of finding the inverse sine without using a calculator. And we said before that as we were evaluating an inverse sine, we were going to look on the right-hand side of our unit circle. So I've got half of a unit circle here available for us to look at. So let's say we wanted to find the inverse sine of 1/2. Now, as we're evaluating inverse trig functions, our answers are always going to be some angle. So what's happening here is we're looking on our unit circle and we're trying to figure out at what angle is the sine value 1/2. So as I'm looking at these ordered pairs on my unit circle, remember the sine value is the y value from the ordered pair. So we're looking for a y value of 1/2 on our circle. And I see a y value of 1/2 happening right here. So the answer we're trying to find is the angle where that happens. And the angle where we have a y value of 1/2 is pi over 6. So the inverse sine of 1/2 is pi over 6. Now if we wanted to find an arc sine of root 2 over 2. Remember, arc sine means the exact same thing as inverse sine. So we're trying to find an angle where the sine value or the y value is root 2 over 2. So if I look right here, we've got a y value of root 2 over 2. So that angle is pi over 4. So our answer is pi over 4. Now let's say we wanted to do the inverse sine of negative root 3 over 2. Now here we're looking at a negative sine value, meaning that we're going to be on the bottom of our unit circle, and I'm trying to find a y value of negative root 3 over 2. So if I look down here, I've got negative root 3 over 2, and that angle is 5 pi over 3. But 5 pi over 3 isn't actually our answer, because of how we had to restrict down the domain of the original sine function in order for its inverse to exist. We said that we had to restrict down those angles to being between negative pi over 2 and positive pi over 2. And 5 pi over 3 is too big to fit in this interval. So there's a couple different ways that we can think about it. One way is if we start at 0 and work our way down to this 5 pi over 3 angle, that's really an angle of negative pi over 3. But another way that we can think about it is using coterminal angles. So if I look at that 5 pi over 3 and I want to work it backwards to find a negative coterminal angle, then I could subtract off a 2 pi rotation. But in order to do this subtraction, we're going to need common denominators. So 2 pi really turns into 6 pi over 3. So if I take 5 pi over 3 minus 6 pi over 3, then again, I get my negative pi over 3. So a couple different ways for us to get to that negative pi over 3 angle, but we do have to make sure that we're adjusting the angle because 5 pi over 3 does not fit in this interval from negative pi over 2 to positive pi over 2. So if I wanted to do an inverse sine of negative 1, I see the y value of negative 1 down here, which happens at an angle of 3 pi over 2. But 3 pi over 2 is too big to fit in this interval. So if we think about working it backwards, then it would be the angle negative pi over 2. Now let's say we wanted to do an arc sine of pi over 2. Now as I'm looking at these y values that are showing up on my unit circle here, I don't see any y values of pi over 2. So I'm going to think about turning this into a decimal. So pi over 2 works out to be about 1.57. But if we remember what we said, the domain for an inverse sine needs to be some number between negative 1 and positive 1. And 1.57 is definitely outside of that interval. So this one does not exist because 1.57 is not in the domain of an inverse sine or of an arc sine. Now one last one we're going to look at. We're going to do an inverse sine of the sine of pi over 9. Now here we've actually got something that we need to do before we evaluate the inverse sine, because if we're following the order of operations, we would need to take care of what's happening on this inner set of parentheses first. So we would be evaluating the sine of pi over 9. But pi over 9 is an angle that doesn't show up on our unit circle. So if we're kind of comparing it to our other angles that we already see on our unit circle, I'm going to approximate pi over 9 to be about right here. Now we don't know the ordered pair for pi over 9, so we just know that it's going to be some general x and y value right now. So really what I could say is that the sine of pi over 9 is just this y value from this ordered pair. But then if I want to evaluate the inverse sine of that y value, that means that we're trying to find the angle where that specific y value happens. And we just got done saying that we were talking about the angle pi over 9. So the inverse sine of the sine of pi over 9 is just the angle pi over 9. Now we can also evaluate inverse sines using our calculator. So we're going to use our calculator in radian mode to evaluate a couple of inverse sines. And the first one that we're going to look at is the inverse sine of 0.75. Now we can't do this one on a unit circle because we don't have a y value of 0.75. So that's why we want to use our calculator. So I'm going to fire up my calculator. So the first one we're supposed to do is the inverse sine of 0.75. So I go second sine 0.75, close up my parentheses, hit enter, and I'm going to go to 3 decimals. So I'm going to call this one 0.848. So going to 3 decimals, we got 0.848 as our answer. Now for the next one, we're going to look at the inverse sine of negative 0.81. And again, we're going to use our calculator because this y value does not show up on our unit circle. So I'm going to fire up my calculator. So we're doing the inverse sine of negative 0.81, close up our parentheses, hit enter, and I'm going to go to 3 decimals again, so I got negative 0.944. And rounding to 3 decimals on this one, we got negative 0.944. And the last one, we're going to do the inverse sine of the sine of 3.49 pi. And again, we're just going to type this one into our calculator. Now in this one, we're supposed to do the inverse sine of the sine of 3.49 pi. I've got 2 sets of parentheses to close up. When I hit enter, again going to 3 decimals, we get negative 1.539 as our answer. So going to 3 decimals on this one, we got negative 1.539. That's going to be it for this video. Thanks for watching.